So, now I did the sound check. Thank you. So let's start converting things in a different direction. So we're going to start with rectangular coordinates and convert things to polar coordinates. So we'll start with problem number 56. We've got the point 0, 2. We want to convert that from x and y to r and theta. So let's ignore the radial stuff on this for a second and just plot this as if it was a regular rectangular coordinate. So 0 for x, 1, 2 for y puts us right there. But let's think about that in terms of r and theta. This one we don't have to do with any necessarily with any formulas. So first of all, what's the radial distance from the origin to our point? What's 2? Don't need anything fancy for that. R is 2. What's the angle? Pi over 2. Yeah. Probably radians is what we'll ask for. I'll be careful to say on the test what I'm looking for. If I'm not, then hey, go for whatever you want. Let's try problem number 60. So negative 3 and 3. Now, negative 3 and 3, well, that's going to be in the second quadrant someplace. So negative 3, 1, 2, 3, and positive 3, 1, 2, 3. They're going to meet out here someplace. So right there. But I need to convert this to r and theta. Now let's keep in mind a couple things here, x and y. One thing we can recall is that r equals the square root of x squared plus y squared. So in this case, that's going to be negative 3 squared plus 3 squared will give us the square root of 18. And I'm not really going to be overly concerned whether or not you clean this up a little bit. Square root of 18 is square root of 9 times 2, or 3 square roots of 2. So, okay, fine. But that's r. Do we really need to do a lot of hard thinking in order to figure out what theta is? Well, if you're at negative 3 and 3, the same direction both times, you have to be on one of these lines, either y equals x or y equals negative x, and they're going to cut through at multiples of 45-degree angles. So 45, 135, 225, and 315, or multiples, odd multiples of pi. So in this case, I wouldn't spend a whole lot of time fussing with this. I'd just say, all right, that's going to be 3 pi over 4. But if you're struggling with this stuff, you're like, well, I'm just not that good with this. I'm not that comfortable with this. Let's keep in mind something else that we can do. Remember, tangent of theta was equal to y over x. That's a formula we developed early on in working with this stuff. So if I plug in here, tangent of theta equals 3 over negative 3. Tangent of theta equals negative 1. Does that help me out at all? Yeah, it does. It would be nice if I could write an actual theta that looked like a theta. Theta is the inverse tangent of negative 1. My suggestion would be to do this in degrees on your calculator. You'll get negative 45 degrees, which is okay to a point. But should our angle be negative 45 degrees? Take a look at where your point is. Your point's up here someplace. So the negative 45 degrees gives us a starting point. Really, we got to end up over here. So another angle that has the same tangent would be 180 degrees away. That is 135 degrees, or better yet, 3 pi over 4. So one way or another, you need to get back to that radius and that angle. Typically, when I ask you to do these problems, I'm going to want r to be greater than 0 and theta to be between 0 and 2 pi. That's what I expect. Yeah, if there's some confusion about that, ask me. All right. If I don't tell you, then ask me, please. Yes.
When you looked at the x, y coordinates of that one, how did you, like for the x value, how did you look at 3 and put it right there? Like I know how you put 3 for left.
Well, 1, 2, 3. It's a little bit more there. I mean, I kind of went up from here, and I probably didn't do a really good job. Up from here and then over here. So I was probably off by a little bit. All right. It was just a guess. Because remember, we were at -3 here and +3 here. So I didn't do a really good mental job of drawing that point.
Okay. I was looking at it wrong, but thank you.
Sure. No, I appreciate you asking the question. Let's do one that you can't just kind of eyeball. And a good example of that would be problem number 62. 62. So -2 and -2 square roots of 3. So I'm going to kind of get away from our graph and polar coordinates, and let's just draw this. What quadrant is that going to be in? 3. Good. It's going to be in the third quadrant. So I'm just going to draw a point in the third quadrant. So -2 in one direction, -2 square roots of 3 in the other direction. Now, regardless of the fact that both of these are negative, the radius is going to be positive. We're going to give ourselves a positive radius here. And we'll start by figuring out what that positive radius is. All right. So let's figure out r first. What's the formula for r? Thank you. Square root of x squared plus y squared. Plug things in. -2 squared plus -2 square roots of 3 squared gives me 4 plus 4 times 3. Sure. When I square this, I get 4. When I square the square root of 3, I get 3. 12 and 4 gives me 16. So the radius here is 4. Great. So I've got both sides. This is -2 square roots of 3, -2, and the radius. There's one last thing that I need, and that is, I need this angle. So you've got your choice of all kinds of different trig functions to find that. I'd probably stick with sine, cosine, or tangent. Those are going to be the easiest ones. But let's try and make it even easier than that. All right, there's no bonus points for making it hard on yourself. What trigonometric function involves this side, and that angle? Well, let's see here. If this is my theta right here, this is the hypotenuse. What side's this? That's not the opposite. That's the adjacent. So it's the cosine that involves that angle, right? So cosine of theta. Now, why did I choose those two? It's going to give you a nice simple ratio, right? You get a ratio of -1/2. So it'd be -2 over 4. So cosine of theta equals -1/2. How am I going to find theta? All right, cosine inverse of -1/2. If I do that in terms of degrees, I get 120 degrees. And clearly 120 degrees is wrong, right? Because 120 degrees is in the second quadrant. We have an angle in the third quadrant. So how are we going to fix it? Negative 120 would work, but I want an angle between 0 and 2 pi.
So it'd be 4 pi over 3.
Yes. So, well, let's understand what's going on here. And let me see if I. There we go. Got my favorite circle. Okay, so here's our unit circle. And cosine is our x-coordinate. What we found is that the angle with an x-coordinate of negative 1/2 is up here. It's at 120 degrees. But I want this angle down here in the third quadrant. If this is 120 degrees this way, that's 120 degrees the other way, so minus 120. What's the positive angle going this way? What's the angle in orange? 240. 240, which is, what's it, 4 pi over 3? 240 degrees or 4 pi over 3. So 4 pi over 3 would be the correct answer here. Or 240, 2 pi over 3, or 4 pi over 3. This one's clearly the one that we want because that's in the third quadrant. Your final answer would be 4 and 4 pi over 3. Yay. Anything else on problem number 62? Feeling a little more comfortable with these? So there's a couple ways. I mean, depending on the point, I mean, sometimes you can kind of eyeball these like we did with problem 56. And to a lesser extent, problem number 60. If that doesn't work, then you can start using your formulas. So, a lot of ways you can work these things. By the way, it would have worked okay if we had chosen sine. It just would have been a little bit different. If I said, well, you know, I want to figure out theta was sine, then the sine of theta would equal the opposite over the hypotenuse. So that'd be negative 2 square root of 3 over 4, or basically negative square root of 3 over 2. When I do the inverse sine, I'll get negative 60 degrees. And I can play the same game with sine that I did with the inverse cosine. If I got a y-coordinate at this height, basically a negative 60 degree angle, then this part here is also 60 degrees. So you can work it that way. All right, there's no more homework because I assigned that in part 1 of this, so we're good.